May 22, 1943. A Consolidated PBY Catalina reconnaissance aircraft banks low over the Atlantic swell, 300 nautical miles southwest of Iceland. The pilot's eyes scan the gray water below with the practiced intensity of a hunter who knows his quarry hunts back. Then he sees it, the distinctive phosphorescent trail of a German U-boat running at full emergency dive. The submarine captain believes his vessel is invisible beneath the waves, shielded by the North Atlantic's gray chaos and the technological limitations that have protected his kind for years. What neither man knows is that from this moment forward, the very act of running his engines in desperation has marked him for death. Within minutes, the Catalina's crew will release a weapon unlike anything in the underwater arsenal. It will descend into the cold darkness without guidance from above, without cable or radio command, and it will listen. It will listen until it finds what it is hunting. This is the story of the acoustic homing torpedo, the British device that transformed submarine warfare and redefined the nature of vulnerability in the deep ocean. It is a story of innovation born from desperation, of engineers who solved the unsolvable, and of a technology so effective that those who developed it almost forgot to tell the world it existed. By 1942, the Atlantic was dying. Merchant convoys from North America, laden with supplies that Britain desperately required, were being slaughtered by German U-boats with a methodical and horrifying efficiency. In the first half of that year alone, submarines sank over 3 million tons of Allied shipping. The mathematics of the situation were grimly straightforward. Britain was fighting for survival. Survival required food, oil, and military hardware from America. And between America and Britain lay a maritime desert patrolled by the most effective submarine fleet the world had yet seen. The escort vessels that accompanied the convoys, the corvettes and destroyers that charged after the U-boats, faced an impossible challenge. They possessed sonar, that revolutionary technology that could detect a submerged submarine through sound waves. Yet once a submarine dived and ran silent, the hunters became hunted. They could hear the vessel's location, but localizing a moving target in 3 dimensions of ocean space was profoundly difficult. The U-boats had learned to run their diesel engines at minimal power, listening through their own hydrophones for the approaching screws of escort vessels. It was a deadly game of hide-and-seek played 300 meters below the surface, and increasingly the submarines were winning. The statistics told a devastating story. In March 1943, a German wolf pack of 40 U-boats attacked a convoy designated SC-122. They sank 13 merchant vessels carrying grain, explosives, and artillery. The escorts sank 0 U-boats in response. This pattern repeated across dozens of convoys. The Royal Navy was numerically dominant in the Atlantic, yet merchant ships were being sent to the bottom with appalling regularity. Something had to change. The Royal Navy's response came not from a battleship or destroyer, but from the basement laboratories of the Admiralty's underwater weapons establishment at Portland, Dorset, where a small team of engineers and physicists faced what seemed like a technological barrier. The fundamental problem was this: a torpedo is a dumb weapon. It runs in a straight line, and if the target moves to either side of that line, the torpedo passes harmlessly by. Conventional torpedoes were therefore fitted with exploding charges that detonated when they passed within lethal range of a ship's hull, hoping acoustic proximity would trigger detonation. But submarines could still evade them. What if a torpedo could think? What if it could hear its target and steer itself towards it? The conceptual breakthrough came from studying how bats hunt in the dark, though the engineering solution required something far more sophisticated than nature could provide. The weapon that emerged from Portland bore the ungainly designation Mark 24 mine, partly because of security classification and partly because the very concept seemed so fantastical that a straightforward name seemed almost insufficient. To those who used it, it became known as Fido, a name with a peculiar affection that many deadly weapons acquire. Fido was roughly 2 meters long and weighed around 300 kilograms. Its warhead contained 60 kilograms of TNT, but what made Fido revolutionary was the mechanism that guided that warhead to its target. Within the torpedo's hull, housed in a watertight compartment, sat an arrangement of hydrophones, extraordinarily sensitive listening devices derived from sonar technology. These hydrophones didn't work like sonar's active pinging, which gave away the hunter's position. Instead, they passively listened for the high-frequency vibrations produced by a diesel engine running underwater. A U-boat's engines produced a distinctive acoustic signature, a pattern of vibrations that varied with the specific model and condition of the submarine. Fido's receiving apparatus could detect these vibrations from distances up to 2,000 meters. Once released and activated, Fido began its search pattern, swimming in expanding circles at a depth of approximately 60 meters. The hydrophones scanned continuously, waiting for the acoustic fingerprint of a submarine engine to emerge from the ocean's ambient noise. The moment those hydrophones detected an appropriate frequency signature, the torpedo's brain, if one could call the mechanical and electrical circuits by such a name, sprang to life. The device would register the direction from which the sound arrived and begin steering towards it. The steering mechanism itself operated through a servo system of remarkable sophistication for the period. Electric impulses from the acoustic processor would activate small hydrofoil planes mounted on the torpedo's tail, deflecting the weapon's course gradually towards the detected sound source. The torpedo would follow its target in a continuous pursuit curve, maintaining velocity of approximately 10 knots throughout its run. This meant that as long as the U-boat continued operating its engines, Fido would relentlessly pursue it. If the submarine attempted evasion by turning sharply, the torpedo's inertia and steady turning radius often allowed it to cut the corner and close the range. If the submarine shut down its engines to run silent, Fido would either activate its backup sonar system or simply cruise on for several minutes before timing out, at which point it would detonate automatically. Manufacturing Fido presented extraordinary challenges to British industry. The acoustic apparatus required precision engineering to tolerances of less than 1 millimeter. The hydrophone elements themselves utilized a piezoelectric effect, whereby crystalline materials like quartz would generate electrical signals in response to sound waves. This technology had existed in theory, but creating reliable manufacturable units that could withstand the crushing pressures of deep ocean water proved monumentally difficult. Production was distributed across 3 facilities. The main assembly work occurred at the Admiralty's facilities at Portland. Component manufacture occurred at factories in Southampton, where the acoustic elements were painstakingly constructed, and at Portsmouth, where the servo systems that controlled the torpedo's rudders were built. By the end of the war, estimates suggest that approximately 2,600 Fido torpedoes were manufactured, though exact production figures remain classified in British archives. The rate of production accelerated steadily throughout 1943 and 1944, such that by the final year of the war, Fido production consumed a significant fraction of Britain's acoustic equipment manufacturing capacity. The first operational deployment of Fido came in May 1943, when RAF Coastal Command aircraft equipped with the weapon began operations in the Bay of Biscay, where German U-boats were forced to transit between their French bases and the Atlantic hunting grounds. The results were immediate and shocking. On May 23, 1943, the U-boat U-456 was operating on the surface when an RAF Whitley aircraft detected it through radar. The Whitley attacked, damaging the submarine and forcing it to dive. As U-456 descended and activated its engines to achieve deeper diving speed, the crew heard an entirely new sound in their hydrophones, the acoustic signature of Fido, actively homing on their vessel. The U-boat's captain, Kapitän-Leutnant Max Herbst, executed every evasive maneuver his boat could manage. He turned sharply, attempted to confuse the torpedo by using his engines inconsistently, even attempted to hide the noise of his engines behind the wake of an escort vessel. Nothing worked. The torpedo maintained its course with inexorable certainty, and on impact, the acoustic detonator triggered. U-456 sank with the loss of 43 crew members. If you are finding this fascinating, do please subscribe. These stories of forgotten innovations deserve to be told, and your support helps us bring them to light. Within weeks, reports of Fido attacks began filtering through the German Naval High Command. The accounts were initially confused and contradictory. Some crews reported being attacked by a torpedo that somehow pursued them underwater despite their evasive maneuvers. Others described sounds like no weapon they had encountered previously. German engineers initially suspected an entirely new class of vessel or aircraft-mounted device, something perhaps operated by a human operator through a cable system. The true nature of the weapon, that it was essentially independent, guided by its own mechanical sensory apparatus, proved genuinely baffling. The German response was constrained by circumstances. Unlike Britain, Germany had not pursued acoustic homing for torpedoes with any great vigor. German engineers had developed their own sophisticated weapons, particularly the G7E electric torpedo, which left no acoustic wake that could betray its presence. However, this weapon had significant limitations. Its batteries required very long recharge times, and it carried a considerably smaller warhead than conventional steam-driven torpedoes. When German engineers finally understood the principle behind Fido, they attempted to develop countermeasures. One approach involved releasing clouds of gas bubbles behind a U-boat, attempting to confuse the hydrophones with false acoustic signatures. Another involved routing the submarine's exhaust through special baffles designed to suppress certain frequency ranges. Neither approach proved particularly effective. The fundamental problem was that Fido's sensing apparatus was simply too sophisticated for the mechanical countermeasures available in 1943 and 1944. The American equivalent to Fido, designated the Mark 54, did not enter service until late 1944 and was initially slower to achieve operational impact. The American weapon was somewhat heavier and incorporated different acoustic sensing arrangements, using electromagnetic recording elements rather than purely mechanical hydrophones. Once deployed, however, the Mark 54 proved comparably effective. German engineers noted that the Anglo-American torpedoes seemed to complement each other in their coverage of different acoustic frequencies and operating depths, such that coordinated attacks from British and American forces became increasingly difficult to defend against. The Italian Navy, using German-supplied submarines, reported similar experiences with Fido attacks, though Italian crews, possessing fewer sophisticated submarines and less advanced training than their German counterparts, suffered proportionally higher loss rates when confronted with acoustic homing weapons. By the final year of the war, Fido had demonstrably changed the mathematics of submarine warfare. In 1943, U-boat losses had been heavy, but the submarines had maintained sufficient success against shipping to make continued operations worthwhile to the German command. By 1944 and 1945, the loss rates had become nearly prohibitive. A U-boat captain heading to the Atlantic in the spring of 1945 knew that statistically he faced worse odds than a bomber pilot on the worst days of the strategic bombing campaign. Fido was not the only reason for this transformation. Improved radar detection, more effective depth charges, better coordinated escort tactics, but it was a crucial factor. The acoustic homing torpedo represented a fundamental shift in submarine vulnerability. For the first time, a submerged submarine running its engines in an attempt to escape a threat could be reliably targeted by an autonomous weapon that required no further guidance from above. The psychological impact on U-boat crews was profound. Experienced crews spoke of a new despair, of a weapon that seemingly could not be evaded. Captured German officers interrogated after the war consistently identified acoustic homing torpedoes as among the most significant technological threats they had faced. The post-war years saw Fido technology adopted and refined by navies around the world. The Soviet Union, through espionage, obtained examples of Fido and rapidly reverse-engineered the design, producing their own acoustic homing torpedoes by the late 1940s. The Americans, unsurprisingly, continued development of their Mark 54 design, which evolved into the Mark 56 and subsequently into the Cold War-era acoustic homing torpedoes that persisted in submarines throughout the Soviet period and beyond. The acoustic homing torpedo became so integral to modern submarine warfare that by the 1960s, virtually every major naval power possessed variants. The British, having pioneered the technology, would develop increasingly sophisticated versions. The Mark 46 torpedo of the 1960s incorporated transistorized electronics and more advanced hydrophone arrays, whilst the later Mark 48 and Spearfish models would employ digital signal processing to achieve even greater discrimination between genuine targets and false acoustic signatures. Yet, the wartime Fido itself, that pioneering device that had transformed submarine warfare in 1943, faded into obscurity. Unlike the supermarine Spitfire, which entered the post-war era laden with glory and recognition, Fido remained essentially forgotten by the British public. No surviving examples remain on public display in Britain. One specimen is preserved in the Smithsonian Institution in Washington, another in the American Naval Museum at Newport, Rhode Island. The Portland establishment where Fido was developed no longer exists in its original form. The engineers and technicians who solved the extraordinary problem of making a torpedo listen have largely passed from living memory. This absence from public consciousness is partly deliberate. For decades, detailed technical information about Fido remained classified. The acoustic frequencies the device detected, the sensitivity of its hydrophone arrays, the specific servo mechanisms it employed, all remained state secrets well into the 1970s, and some aspects were never fully declassified. Classification erased the weapon from popular memory more effectively than any amount of genuine secrecy could have managed. What is not publicly acknowledged struggles to remain in public consciousness. Yet the facts of Fido's achievement remain extraordinary. Between its introduction in May 1943 and the war's end in May 1945, Fido-equipped aircraft and vessels are credited with sinking or contributing to the sinking of at least 18 German U-boats. Conservative estimates suggest that Fido either sank or severely damaged U-boats responsible for the loss of approximately 200,000 tons of Allied shipping. Stated differently, by stopping German submarines that would otherwise have sunk merchant vessels, Fido saved the lives of thousands of merchant sailors and ensured the continued flow of supplies that allowed Britain and other Allied nations to prosecute the war. The technological principle that Fido embodied, the use of passive acoustic sensing to guide a weapon against a moving target, became foundational to modern warfare. Every acoustic homing torpedo employed by every navy today uses essentially the same principles that British engineers developed in the Portland laboratories. The genius of Fido was not its complexity, rather it lay in its elegant simplicity. The submarine engine creates acoustic vibrations. These vibrations can be detected. A weapon can steer towards these vibrations. Therefore, no submarine engine can run without creating a potential vulnerability. What the U-boat captains of 1943 had not grasped, what they could not grasp, was that the very mechanism keeping them alive, the diesel engines that powered their escape, had become their executioners. On a summer morning in 1946, the last surviving Fido torpedo was taken out to the Irish Sea and detonated in a controlled explosion, its remaining fuel and explosives rendered harmless. The weapon had served its purpose. The war was over. Britain was exhausted and pivoting towards an uncertain peace. Few paused to reflect on the remarkable achievement that Fido represented, that moment when desperate necessity had been transformed into technical genius, when the impossible had become routine. The U-boat menace was vanquished, though not by virtue of any single weapon, but rather by the aggregate weight of improved tactics, better intelligence, and innovations like Fido that had steadily eroded the submarine's advantage. Today, if we were to ask a randomly selected Briton what technological innovations Britain produced during the Second World War, most would name the radar systems of Fighter Command, the machinery of Bletchley Park, perhaps the Mulberry Harbors of the Normandy invasion. Fido would not appear in their recollection. Yet in its own domain, in the particular domain of submarine hunting, Fido was as revolutionary as radar was to air defense. It was a weapon that forced submarines to choose between remaining silent and invisible, or remaining mobile and doomed. There was no third option. The German Navy made that choice, and thousands of submarines' crews paid the price. The acoustic homing torpedo represented the moment when humans first created a weapon that could pursue its target through mechanical senses, that could make decisions about its course based on stimuli from the environment. In that respect, Fido was not merely a weapon of war, it was a precursor to an entirely new age of autonomous warfare. That the world largely forgot it is perhaps one of history's more remarkable ironies.